Valence electron configurations indicate electrons and orbitals that are likely to be involved in reactions. Another common configuration we call the full electron configuration. This is a listing of all the electrons in an atom. Now, as you might guess, this could become somewhat tedious for atoms that have a lot of electrons, so we'll come up with a shortcut for that. The full electron configuration is a listing of all of the elements in an atom. If we understand how the blocks of the periodic table are constructed, this becomes a task of reading the periodic table like the page of a book. Let's use potassium as an example. We find potassium as element number 19. The valence electron configuration would be 4s1. But for the full electron configuration, we want to list all of the electrons. Reading the table like the page of a book, we first come to hydrogen, then helium. Thus, the full electron configuration starts out 1s2. The next two elements, lithium and beryllium, are in the s block and represent filling the 2s sublevel with 2 electrons. We add 2s2 to the configuration. Next come elements 5 through 10 in the p block, representing 2p6. Next comes 3s, which we can add to the configuration. Following that is 3p6. Finally, we get to potassium, which finishes our configuration with 4s1. We can use this technique with any element on the periodic table to write the full electron configuration. As we said before, this can get quite tedious for elements farther down the table, so we'll introduce what we call the noble gas abbreviation. Notice that for any element in the fourth period, the configuration will start out 1s2, 2s2, 2p6, 3s2, 3p6. This happens to be the configuration of the element argon. As a shortcut, then, we can show the electron configuration of potassium as the symbol for argon in square brackets 4s1. The argon in square brackets is equivalent to writing 1s2, 2s2, 2p6, 3s2, 3p6. So, to use the noble gas configuration, we go to the noble gas in the period above our element and write its symbol in square brackets. Then we include all of the rest of the electrons corresponding to the period in which our element resides. This gives us the full electron configuration.